Hi everyone, this is Noli Pomentil, a second-year college student taking a Bachelor of Science in Geodetic Engineering at the Visayas State University, and I'm your lecturer for the part 3 of the mathematics tutorial. Mathematics is considered one of the most challenging and stimulating domain in the DOST scholarship examination. It tests your critical thinking skills, problem-solving skills, and quantitative reasoning ability. Today, I'll be teaching you how to solve some of the most common mathematical problems that appear in the said exam. In this video, we will talk about problems in algebra, sets, series and sequences, and for the part 4 of the lecture, we'll tackle statistics and probability and trigonometry. Word problems are very common in any aptitude tests and can be classified into different types such as age problems, mixture problems, work problems, and number word problems. To solve word problem, converting it into algebraic expression is a must. Word problems contain terms and phrases that have equivalent mathematical operations and expressions. Here are some examples of terms and phrases with their corresponding mathematical operations and expressions. Take a moment to pause this video and read these terms and phrases. Now, get your pens and papers and be ready to solve the problems with me. Let's start our first example with the age word problem. LJ is now 5 years more than twice Rafael's age. 3 years ago, LJ was 3 times as old as Rafael. How old was LJ 3 years ago? A. 21, B. 24, C. 27, D. 30. To solve this problem, we're going to draw a table. In making the table, we must first identify the number of people involved and the time frame present in the problem. The number of people involved will determine the number of rows, while the number of time frame will tell how many columns we need to draw. In this problem, we have 2 persons involved, LJ and Rafael. So we'll draw 2 rows. And for the time frame, we have now and 3 years ago, so which means we need to draw 2 columns. So, this is how the table will look like. Now let's read the problem once again. LJ is now 5 years more than twice Rafael's age. So what we're going to do now is to fill in the now column. Let's assign first a variable to the person whose information was not given. And based on this statement, we have information about LJ's age. Therefore, we'll assign Rafael as X. Since LJ is 5 years more than twice Rafael's age, we'll multiply 2 to X and add 5. Now let's fill in the second column. Time frame could be further classified into past, present, and future. If it's in the past, we have to subtract, and if it's in the future, we have to add. In this problem, we are talking about their age 3 years ago. Therefore, we have to subtract both expressions by 3. And 3 years ago, LJ was 3 times as old as Rafael. To satisfy this statement, we have to multiply Rafael's age 3 years ago by 3. Since we've converted the problem into mathematical expressions, we can now equate them. So we'll have here 3 times x minus 3. Notice that we multiplied Rafael's age 3 years ago by 3, which is equivalent to LJ's age 3 years ago. So we'll have 2x plus 5 minus 3. Now distribute 3 at the left-hand side and subtract 5 to 3. We'll have 3x minus 9 is equal to 2x plus 2. Then combine like terms, we'll have 3x minus 2x is equal to 9 plus 2. Now, we'll have x is equal to 11. So we already have a value for x, but we are looking for LJ's age 3 years ago. Let's simply substitute x to 2x plus 5 minus 3, which is LJ's age 3 years ago. So we'll have 2 times 11 plus 2. We'll have 22 plus 2. Therefore, LJ's age 3 years ago is 24. Our answer is letter B. For some, constructing algebraic expressions is a little confusing and they find it difficult. But don't worry because we have an alternative solution for this kind of problem, and it is through trial and error method. Let's try solving this problem using the said method. In trial and error method, we also need to draw the table, so assume we already have the table. Let's try letter A. LJ's age 3 years ago was 21. In trial and error method, we are going to work backward. This means that we are going to use the exact opposite operation given in this statement. So to find Rafael's age 3 years ago, we'll have to divide it by 3. We'll have 7. To find Rafael's age now, we'll have to add 7 to 3, so we'll have 10. And to find LG's age now, let's follow the statement. We'll multiply 10 to 2 and add 5, so we'll have 25. Notice that LG's age now is 25, but 3 years ago he was 21, which is obviously incorrect. So letter A is incorrect. Now let's try letter B. LG's age 3 years ago was 24. To find Rafael's age 3 years ago, let's divide it by 3, we'll have 8. And let's add 3. To find Rafael's age now, we'll have 11. And to find LJ's age now, let's multiply it to 2 and add 5, we'll have 27. So LJ's age now is 27, and 3 years ago he was 24, while Rafael is 11, and 3 years ago he was 8. This table now satisfies the statement above, therefore letter B is our answer. Using two different methods, we have arrived at the same answer. Therefore, you can use any method, but please remember about the time. Now let's move on to the second problem, which is a mixture problem. A 45% solution is mixed with 20 liters of pure water to form a 30% solution. How many liters of the original solution did we start with? A. 15, B. 25, C. 40, D. 45. Solving mixture problems, let us use this formula, which can also be represented using this illustration, where A is equal to the volume of the first solution, B the volume of the second solution, X is equivalent to the concentration of the first solution, Y is equal to the concentration of the second solution, and Z is equal to the concentration of the mixture. Now let's determine the given. We have here the concentration of the first solution, which is 45%, and 20 liters, the volume of the second solution. Since it is mixed with pure water, it means that there is no concentration of the second solution. And we also have here 30% solution, which is the concentration of the mixture. So what is being asked in the problem is the volume, the liters of the original or the first solution. So we need to find A here. Now since we have the given, let's substitute it to the formula. We'll have A times 45% plus 20 times 0 is equal to quantity A plus 20 multiplied to 30%. We can change percent into decimal form by moving 2 places to the left. We'll have A times 0.45 plus 20 times 0 is obviously 0 is equal to A plus 20 times 0.30. What will remain is A times 0.45, and at the right hand side we'll distribute 0.30. We'll have A times 0.30 plus 6. Now we can combine like terms. Let's subtract 0.45A to 0.30A is equivalent to 6. Subtract 0.45 to 0.30, we'll have 0.15. Then divide both sides by 0.15 to find the value of A. And our value of A would be equivalent to 40. So our answer for this problem is letter C. Let's have another example. 25 liters of a 10% alcohol solution is mixed with 50 liters of a 25% alcohol solution. What is the concentration of the mixture? A. 18%, B. 12%, C. 15%, D. 20%. To solve this problem, we'll refer to the same formula. This time, let's put the given to the illustration so that you'll understand how the problem really works. So we have here 25 liters, the volume of the first solution, and 10% the concentration of the first solution, 50 liters the volume, 25% the solution of the the concentration of the second solution. So what is being asked in the problem is the concentration of the mixture, which is Z. So let's substitute the formula. We'll have 25 times 10% plus 50 times 25% is equal to quantity 25 plus 50 times Z. So 25 and 50 is A and B. We'll just have to add it. We'll have 75Z. And then we change percent into decimal. Then multiply. We'll have 2.50 plus 12.50 is equivalent to 75Z. Add 2.50 and 12.50. We'll have 15 is equal to 75Z. And then divide both sides by 75 so that we'll find the value of Z. We'll have Z is equal to 0.20. This is in decimal form, so we'll have to change it into percent form. So Z is equivalent to 20%. Our answer in this problem is letter D. In mixture problem, you just have to identify the given and then determine what is being asked in the problem. Just remember the formula and this problem will be easy and simple. Let's move on to another type of word problem, which is the work problem. An inlet pipe can fill a tank in 6 hours and an outlet pipe can empty a tank in 8 hours. If they are both left open, how many hours will it take to fill up the tank? A. 24 hours, B. 20 hours, C. 27 hours, D. 12 hours. In work problems, we are talking about work related to time. Let's refer to this formula to solve the problem, where T sub 1 is equal to time taken by the first object, T sub 2 is equal to time taken by the second object, T sub T is equivalent to the time taken if both objects work together. The first object, an inlet pipe, can fill a tank in 6 hours, while the second object can empty a tank in 8 hours. Notice that the second object is doing the exact opposite work of the first object. Thus, instead of using addition as the operation in the formula, we're going to use subtraction to find the time taken as both objects work together. Now we have here the equation 1 over 6, and as you can notice, we use subtraction as the operation, minus 1 over 8 is equal to 1 over T sub T. Now let's find the greatest common factor of 6 and 8. We have 24, then divide it to the denominator and multiply to the numerator. We have 4 over 24 minus 3 over 24 is equal to 1 over T sub T. We have 1 over 24 is equal to 1 over T sub T. Now let's cross multiply. We have T sub T is equal to 24 hours. So our answer in this problem is letter A. For the second example, James can finish a job in 6 hours, Andrea can finish a job in 9 hours, and Jane can finish a job in 8 hours. How long will it take them to finish a job if they work together? A. 6 hours, B. 4.5 hours, C. 2.5 hours, D. 2 hours. First, let's determine the given of this problem. We have James who can finish a job in 6 hours, Andrea can finish a job in 9 hours, and Jane can finish a job in 8 hours. Notice that we have 3 persons involved, and to solve this, we simply add another expression or fraction to the formula we had from the first work problem. Now let's simply substitute the given to the formula. We'll have 1 over 6 plus 1 over 9 plus 1 over 8 is equal to 1 over T sub T. Find their greatest common factor. We have 72. Then get the numerator. We'll have 12 over 72 plus 8 over 72 plus 9 over 72 is equal to 1 over T sub T. Then add, we'll have 29 over 72 is equal to 1 over T sub T. Then let's cross multiply. We'll have 29 T sub T is equal to 72. Now to find the value of T sub T, let's divide both sides by 29. We'll have 2.48, which is approximately 2.5 hours. So our answer for this problem is letter C. Now let's talk about the last type of word problem. We have here the number word problem. Find the largest of the 3 positive integers if the second is 6 more than the first, the third is 4 less than 4 times the first, and the sum of the square of the first integer plus the product of the second and third integers is 276. A. 8, B. 12, C. 16, D. 20. To solve this problem, we'll assign x to an integer whose information was not given. Since we do have an information about the second and third integer, we'll assign x to the first integer. To create an expression for the second integer, let's add 6 to x based on the given statement we have above. And for the third integer, we'll multiply 4 to x and subtract 4 since the third is 4 less than 4 times the first. Notice the arrangement of the expression. Instead of writing 4 minus 4x, I wrote it as 4x minus 4. The arrangement in the expression plays a big factor in finding the correct answer. So try to deeply understand the problem first before creating expression. Now let's focus on the other half of the problem. It states that the sum of the square of the first integer plus the product of the second and third integer is 276. So we have to add the square of the first integer, so we'll have x squared plus the product of the second and third integer. We'll have x squared plus x plus 6 times 4x minus 4 is equal to 276. Let's multiply x plus 6 and 4x minus 4. We'll have x squared plus 4x squared minus 4x plus 24x minus 24 is equal to 276. Now let's combine like terms. Add x squared and 4x squared, which is equivalent to 5x squared. Subtract 4x and 24x, will have 20x. And then copy negative 24 is equal to 276. Now transpose 276 and put it at the left hand side. We'll have 5x squared plus 20x minus 300 is equal to 0. They are all divisible by 5, so we can factor out 5. We'll have here x squared plus 4x minus 60. Then factor. We have x plus 10 times x minus 6. We have two values of x, which is x is equal to negative 10 and x is equal to 6. But what is being asked in the problem is a positive integer, so we'll use 6. And then we can substitute 6 to the expression of the second and third integer. We have x plus 6, substitute x, we have 6 plus 6 is equivalent to 12. Then for the third integer, we have 4x minus 4. We'll have 4 times 6 minus 4, we'll have 20. So we have now the three positive integers, which is 6, 12, and 20. But we are being asked again for the largest, so our answer is 20. We have letter D. Let's try another number word problem. The product of the two consecutive negative even integers is 48. Find the larger integer. A negative 4, B negative 6, C negative 8, D negative 10. This problem is pretty simple. First, let's assign a variable to one of the integers. This problem will let n be the smaller integer. Since we are looking for two consecutive even integers, this means that the integers are 2 units apart from each other. For example, 2 and 4 and 8 and 10. 2 and 4 are 2 units apart from each other and they're both even numbers, while 8 and 10 are also 2 units apart from each other and they're also even number. So, for the second integer, for the larger integer, we'll have to add 2, so we'll have n plus 2. Now, since we have here the product, which is 48, this means that we have to multiply to find the value of n. So, we'll have here n times n plus 2 is equal to 48. Distribute n. We have n squared plus 2n is equal to 48. Transpose 48, we'll have n squared plus 2n minus 48. Then factor. We have n plus 8 times n minus 6 is equal to 0. So, we have now values of n. We have negative 8 and positive 6. But we are being asked for negative integer, so we'll use negative 8. Now we just have to find the larger integer by simply substituting negative 8 to the value of n, so we'll have n plus 2, which is negative 8 plus 2, so our larger integer is negative 6. This means that our answer for this problem is letter B. Now let's move on to our next topic, which is all about set. A set is a collection of objects that have something in common or follow a rule. The objects in the set are called its elements, and set notation uses curly braces with elements separated by commas. Let's read our first example. Given is set A with elements Liza, Chera, Christina, Natasha, Leia, and Anjali. Set B contains Ace, Erica, Kay, Jaira, Liza, Ian, and Gerald. If sets A and B represents the friends of Cedric and Clarence respectively, what does A intersection B represent? A, the friends of Cedric who are not friends of Clarence. B, the friends of Clarence who are not friends of Cedric. C, the common friends of Cedric and Clarence. D, the combined friends of Cedric and Clarence. To solve this problem, let me first discuss to you some of the set operations. Let's start with union with the symbol U, denoted as A union B, is the set containing all elements that belongs to either set A and B. So we have here an example, and A union B contains elements that belongs to either set A and B. To easily remember what union means, just remember the word combine. So we're talking about the combined elements found in the set. For intersection with its symbol inverted U, denoted as A intersection B, it is the set composed of all elements that are both in A and B. So for A intersection B, it contains all the elements common in the sets. For set difference, A minus B, it is the set where the elements present in A that are also in B are deleted in A. So we have here another example. As you can see, the common element in A and B is deleted in A, and what remains are the unique elements of set A. Now, since we understand this operation, let's go back to the problem. So we are being asked, what does A intersection B represent? And as I mentioned a while ago, A intersection B contains the common element found in both sets. So our answer here in this problem is letter C, which is the common friends of Cedric and Clarence. Letter D talk about the combined friends of Cedric and Clarence, thus this is union. And letter A and B are examples of set difference. Now let's move on to our second problem. If there are 12 students who love twice, and 8 who love EC, and 6 who love both, how many students love twice or EC? A 14, B 12, C 10, D 8. In this problem, we are talking about cardinality of set, which is the number of elements in a set and represented by state bars where A can be any set. So here's an example. To find the cardinality of set A, which contains element 1, 2, 3, 4, 5, we just have to count the number of elements. We have 1, 2, 3, 4, 5. Thus, cardinality of set A is 5. So as simple as that. Now let's go back to the problem. This problem can be best represented using a Venn diagram. A represents for twice and B represents for EC. The common part or the common region, overlapping part of the circle, is where the number of students who love both twice and EC belong. To find the number of students who love twice exclusively, let's simply subtract 12 to 6, so we'll have 6. So the number of students who love twice exclusively is 6. And to find the number who love EC alone, let's simply subtract 8 to 6, we'll have 2. Now since we have the number of students who love twice alone, who loves EC alone, and who loves both EC and twice, now we can just simply add these three numbers to find the cardinality of A union B, which is the total number of students who love twice or EC. So we have 14. Our answer is letter A. For the last problem in set, find complement of A if A contains element A, B, C, D, E, B contains element B, C, D, E, F, C contains element A, B, C, G, H, I. A element B, C, B element A, B, C, D, E, C elements F, G, H, I, D elements A, B, C, D, E, F, G, H, I. Let me first explain to you what complement means. It is denoted as complement of A, which contains all elements not in A. This means that we are looking for elements that are not found in a specific set. So to solve this problem, let us first list down the sets. We have set A, B, and C. Now let's find the elements in A that are found in B and C so that we could delete the elements, and what remains are the elements that are not found in A. So we have here A, B, C, D, E, and in set B, we can see that B, C, D, E are present, and in set C, we have A, B, C. So what remains are F, G, H, I. Thus, complement of A are elements F, G, H, I. Our answer is letter C. And for the last part of the part 3 of the mathematics tutorial, let's talk about series and sequences. A sequence is defined as an arrangement of numbers in a particular order, and on the other hand, a series is defined as the sum of the elements of a sequence. We have here a first example. A choir is about to perform on a stage with 10 choristers placed in the front row and 3 additional choristers in each successive rows. If there are 10 rows, how many choristers are there in the last row? A 34, B 37, C 40, D 43. The first row has 10 choristers, and each successive row we have 3 additional choristers. So from 10 we'll add 3, therefore we have 13, and add another 3 we'll get 16. This is an example of an arithmetic sequence problem, and to solve this, we use this formula where A sub 1 is equal to the first term, D is equivalent to the common difference, and N is the nth term of the sequence. Our first term is 10, And since we add 3 in each row, our common difference is 3. What is being asked in the problem is the number of the choristers in the last row, which is the 10th row. Therefore, Rn is 10. Now, let's substitute the given to the formula. We'll have a sub 10 is equal to 10 plus 10 minus 1 times 3. 10 minus 1 is 9. Multiply 9 and 3, we'll have 27. Add 10 to 27, we'll have 37. So, our answer in this problem is letter B. Let's have our second example. A choir is about to perform in a stage with 10 choristers placed in the front row and 3 additional choristers in each successive rows. If there are 10 rows, how many choristers are there to perform? A. 235, B. 240, C. 245, D. 250. We have the same situation and given, but this time we are being asked if how many choristers are there to perform. Therefore, we need to use the arithmetic series formula. 10 is our n, since we have 10 rows. A sub n, which will be A sub 10, is equivalent to 37 based on our answer in the first problem, and A sub 1 is equivalent to 10. Now, let's substitute the given to the formula. We'll have S sub 10 is equal to 10 over 2 times quantity 10 plus 37. Divide 10 by 2, we'll have 5. Multiplied to 10 plus 37, add 10 and 37, we'll have 47. And 47 times 5 is equivalent to 235. So, our answer is letter A. We can use another formula with trying to determine A sub n. What we need to find the sum of the arithmetic series is the first term, the common difference, and the nth term of the sequence. Now again, let's substitute the given to the formula. We have S sub n is equal to 10 over 2 times 2 times 10 plus 10 minus 1 times 3. Divide 10 by 2, multiply 2 times 10, and subtract 10 minus 1, we'll have 5 times 20 plus 9 times 3. We'll have 5 times 20 plus 27. Add 20 and 27, we'll have 47. Then multiply to 5, we'll have 235. So our answer in this problem is letter A. So we have the same result. Using the formula that we are going to use in the problem depends on the given. If A sub n is given, we can use the first formula we had. But if it is not given, we can use this second formula. For our problem number 3, what is the positive value of k if the numbers k plus 8, 20, 20k form a geometric sequence? A. 1, B. 2, C. 5, D. 7. This problem is about geometric sequence. If in arithmetic sequence we have a common difference, in geometric sequence we have a common ratio, which is the amount we multiply each time in the geometric sequence. So we have here an example, 2, 6, and 18. And they have a common ratio, which is 3. If you multiply 3 to 2, we'll have 6. And if you multiply 3 to 6, we'll have 18. So that's how geometric sequence work. Now let's solve the problem. To solve this problem, we are going to use this formula. Our third term is 20k, and our second term is 20, and our first term is k plus 8. Let's simply substitute them. We'll have 20k over 20 is equal to 20 over k plus 8. Now we can cancel 20. At the left hand side, we'll have k is equal to 20 over k plus 8. We can cross multiply. We'll have k squared plus 8k is equal to 20. Now transpose 20, we'll have k squared plus 8k minus 20. Then factor, we'll have k plus 10 times k minus 2. So we have now two values of k, which is negative 10 and positive 2. But we are looking for positive value, so our answer is letter B. Let's proceed to the last problem of the part 3 of this lecture. Find the missing term of the sequence 6, blank, 12. A 12, B 11, C 8, D 5. Some of you might have assumed that the missing term is 9, because if the missing term is 9, this could generate an arithmetic sequence. However, 9 is not in the option. Therefore, this is a different type of sequence. Now, let's first determine what type of sequence is this. Actually, this sequence is an example of a harmonic sequence, which is a sequence of numbers such that their reciprocals form an arithmetic sequence. To solve this problem, let us first find the reciprocal of 6, blank, and 12. So we have 1 over 6, blank, 1 over 12. Now, to find the missing term, let us determine the common difference of this new arithmetic sequence. To find the common difference, let's use this formula. D is equal to third term minus first term over 3 minus 1.
3 and 1 comes from the position of the numbers. They are from third term and the first term. Now we can substitute the third term and the first term. We have 1 over 12 minus 1 over 6 over 3 minus 1. Get the last common denominator of 12 and 6. We have 12 and get the numerator. Subtract 3 minus 1, we'll have 2. We'll have 1 minus 2 over 12 divided by 2. Subtract 1 and 2, we'll have negative 1 over 12 divided by 2. So negative 1 over 12 divided by 2 is equivalent to negative 1 over 24. So we have now our common difference. The next thing that we have to do is to simply add the common difference to the first term so that we could determine the second term. We have 1 over 6 plus negative 1 over 24. Determine the last common denominator. We have 24 and then get the numerator. Subtract 4 minus 1 over 24. We'll have 3 over 24. Simplify, we have 1 over 8. Now we have the missing term, but it is in arithmetic sequence. What we are looking for is the missing term of the harmonic sequence. Let's change it back to the harmonic sequence. We'll have 6, 8, and 12. So the missing term of this sequence is 8. Our answer is letter C.
And we're finished with the third topic. Stay tuned for the part 4 of the mathematics tutorial.